Welcome you all to this video lecture. So here in this video lecture, we are going to discuss regarding to the top topic of instruction execution. So the basic concepts. So before we have discussed regarding to the top system bus. So from that we are going to get to this topic instruction execution. Here we are going to have a picture over to what is meant by an instruction, how those instructions are get executed with using such instruction codes such as add, load, store, subtract, add. So those things is we are going to get discussed with respect to the top the program counter, instruction register, fetch, decode and execute options is also. So from where we are going to how we are going to fetch those instructions is under the program counter increment process, and followingly that of with respect to that of 5 stage risk executions. So RAC executions. So in that primarily we have discussed in the previous class or else in the basic introduction regarding to the RAC and CASC instruction fetch, decode, execute, memory access and the write back options. So using that we are going to discuss here this instruction execution. So from this instruction execution, initially we need to have the picture regarding to the what means meant by an instruction. So simply we can say that this instruction is nothing that how to say it is a binary coded command only. So just simple thing, it is a binary coded command. Here it will automatically says us to the processor. So this binary coded command will automatically tells the processor what to do, which means that what operation you need to perform or else you need to do. So automatically this program may consist of what, a sequence of instructions as where it can be placed, it will be stored in a memory. So these instructions which means that each instruction contains what, when we are going to store in a memory, it has what, it is a information. So each instruction contains an information that allows the processor to determine what the operation and the operands involved. So those operands and operations are such as we are going to say with an example, add instruction, load, store. Using those things as we are get performed over with this process of this instruction. Simply we can say that the processor what will do, it will raise these instructions from where, memory, one after one another, and it will get executes them according to that of what sequence, the program sequence. So already we have the clear picture regarding to that of program counter. So again I am also saying that what is my program counter is nothing that whenever we ask a PC, which means that the program counter, we need to have this thing is that it will tells the processor where the next instruction is located, which means that simply we can say this PC will tells us that the processor where the instruction, so where the instruction is located. So automatically it will sells that. So similarly this IR instruction register will tell what means, it tells us, which means that the program counter tells what, where the instruction is, while this IR instruction register tells, which means that it will holds the instruction currently being processed. The instruction for IR, the instruction uh, currently being processed. So this is told by the IR. So followingly, with respect to this, the RISC styles, the fetch, decode, and execute process we are going to see here over this. So in similar, which means that with respect to that of a basic level, the instruction executions can be understood using these three steps, such as this fetch, decode, and execute. So initially, which means that the first the processor will fetches the instruction from where, from memory. Next, it will do is the what the process decode. So what it will decode, decodes the instruction, what to do to determine what operation is required, which means that it will which is mentioned in the in fetch process. So finally, at last, it will what, it will do the execution process. It will execute the required operation by using what, the appropriate the processor hardware. So this normally this is what means, this is the fundamental instruction execution cycle. So simply we need to get a thing over here is the fundamental instruction execution cycle. What this fundamental instruction execution cycle says, what? Fetch, F, decode and execute. So fetch, decode and execute, these are the things are the fundamental instruction execution cycle. So in that, this instruction fetch, PC increments is all these things is we are going to here we are going to see over here. So this instruction fetch, so how this instruction fetch will be performed over here means, so from program counter and address buses will be defined over there. So by using this address bus, it will fetch over to the top memory. There it will get some data. You then using the database operation, it will go for this IR instruction register. So first thing we need, it will do the process from where? Program counter. From the program counter, it will get moved back to the top address bus. Then it will go move back to the top memory database IR. So which means that here this database will relate over to that our previous topic system bus. So this instruction fetch will perform this operations. Normally the PC contains what? The address of the instruction that we need to get executed. Correct? The next what thing, the processor send these addresses where to send, it will send to that memory through the what? Address bus. And now it will generate what? A memory read control signal. So then this memory returns where from that instruction through the data bus. So then the instruction is then loaded into the memory, sorry, instruction register. So the next is the program counter. This, sorry, PC increment. So this PC increment will tells what means here the exact increment depends on what? The processor architecture. So automatically this processor architecture and instruction format says is this the program counter increment. So this program counter increment is the basic idea is that the program counter keep tracks us with respect to the of next instruction. So normally the program counter what do, it will keep track to of the next instruction. So this exact increment depends on the of what? The program architecture. So this is the things that we need to have clear picture over here with respect to the program counter increment. So the next is the instruction decode. So this instruction decode which will do the processes with respect to that of what means here this decoding things which converts the binary instruction into the control requirements needed for the instructions. So let's for an example, if I give an instruction such as add R3 comma uh, add R3 comma R4 comma R5. So first thing is the operation we are going to perform here is what? Add operation by using the source registers. Here the source registers are R4 and R5. R3 is the destination register. So automatically this decoding converts the binary instruction into the control what requirements needed for that executions. So the next thing is the execute. So this execute will perform as what means once the instruction has been decoded, now it will performs the instruction of processor instruction required for that operation. So actually the operation depends on the instruction only. For an add instruction, the ALU performs as what operation? Addition operation only. Not it will performs the load and store operation. So from the load instruction, the processor calculates the memory address and reads the data from the memory. For store instruction, the processor what will do? It will write the data from the register to into a memory. So therefore, the execution is not the same to other of every instructions. It will depends vary with respect to that of another instructions is only. So the next is the 5 stage RISC executions. So this 5 stage executions is depends with respect to the top IF, ID, EX, memory, and WB write back. So already in the previous sections also we have discussed regarding to this what this will do performs all those things is at all. So here this IF, ID, EX, MEM, and WB says is what means. So IF instruction fetch obtains the instruction from the memory. ID instruction decode, it will do performs as and register read identifies what the instruction and obtains as the required register operands. So next thing is the execute, it will what will performs as the ALU operations or calculates as an effective address, whereas this memory access is used when the instruction requires the memory access. Finally WB write back, So the write back cells is what? The writes us the result into the destination register. So the simply things is already we have discussed regarding this add R3 and R4 and R5 in this video also. So the final thing we need to have a clear picture over here is the thing is the final flow relates from the system bus to current is first from the system bus SB system bus, it will go to the PC program counter. Next fetch, so next IR, next decode, next a register read RR, next it will execute that. Then after execution it will go to the ALU where the memory incorporations are get done. Next is the write back WB. So after write backing that, the next instruction following to that of next instruction mentioned. So using what? The control signal. So this is the term that will involve over this. So from this we can clearly know, now we are able to get identify or we need to know what the processor has to do. So the next thing we need to clearly tells, which means the next question which we need to arise is that who tells the register file, ALU memory interface and other hardware components is exactly what to perform these operations. So those things is will take places to that of next topic named the hardware component control and control signals of the processor in the upcoming videos with respect to that of direct memory access. So DME. Thank you.